This is my first video, and in this video I'm going to introduce a new technique in C++, precisely C++ 220 and later, to a new technique to customize your framework. This is the alternative way to the traditional way, to the traditional macro. For example, a macro like this, if we define it somewhere ahead of any other code, and then we can use the if directive in the code in the further implementation. Say if this football feature is defined, then we do something, or if not, we do something else. For example, if use football feature is defined, then we declare the football class like this. If it's not, then football class, maybe it's something else, maybe it's not defined. And in the user code, it's generally also detect the definition of use football feature macro. If it's defined, then for example, then we use so this is the C way, and traditional C++ way to customize your code. So we define this use football feature macro. If it's defined, then full is happen. If it's not defined, then full is not happen. We can let this definition to decide by user put it here. So it's basically, well, no, it won't happen. It won't allow us to do this. It's not happen because if define the use football macro feature here, the preprocessor won't see it, and football is not defined. So this is the traditional way to customize your code using macro. And now in this video, I'm going to introduce the new one using a template constexpr. Looking like this. Say this is like a compile time customization point. Compile time customization feature. So for example, if we can say that if this template is defined, if football feature is enabled for T, then we implement a class. Yes, let's say it's a base class. We give it a value. Okay, let's make it simple. And we make a specialization, for example. Pull specialized for the second argument. And the second one gives value 2. So this is the basic, this is an example usage for the constexpr Boolean template customization feature like this. For example, the usage code is looking like this. For example, I define a base class in user code, and the example so my example is a example base, my base. So if the code is written like this, the value will be 2, because by default enable fullbar feature is not set for my base. So let's run it. Okay, include the main. Right, because it's not default, because it's false. So enable fullbar feature for my base is equal to false. So, and the false goes to the first one. If it's true, it goes to the second one. Let's see, we do this, we do a customization. create a specialization for the end for the customization context for my base. Let's see what happens now. Oh, it becomes 2. So this is how it works. This is how it works. This is very useful for large C++ frameworks or library implementation. It can avoid using the the traditional C macros and if else directive and make it still make your code customizable. And the most importantly that enable football feature is part of your language of the, I mean if you use the macro approach, if you define somewhere some if you switch on or off part of your code using the if else directive, the code be turned off is not part of your source code actually, because the preprocessor will eliminate the disabled code, the disabled lines. So this is very different. In our new approach, the constexpr approach, enable football feature is part of our entire language. I mean, no matter where it's defined or not, you can see it everywhere. The difference is that if you customize it using a template specialization, yeah, then it will give us a different result. This is how we construct the type at compile time. So this is very useful. I hope this is how useful for you. Bye.